Hello students, welcome back. Today we will study about the relation between resistivity and relaxation time. Why after all we are trying to study this? Just because it is asked in exams? No. Actually we are trying to understand the reason behind the conductors. In conductors the resistivity increases with increase in temperature. Why? We are trying to find the answer for this because we are being told and we understand it intuitively that unlike semiconductors, in semiconductors with increase in temperature, the conductivity increases. It starts behaving like a better conductor and conducts properly. But in conductors with increase in temperature, it is the resistivity which increases. Why is this so? Why is the difference in the behavior? So for understanding all these things, we are trying to understand the relation between resistivity and relaxation time. Now we know both these terms, resistivity you know and relaxation time also you know. We have covered it in the previous episodes, you can check it out. It is the time interval between two successive collisions. It is the time of rest. It is the time in which the electron is not undergoing any of the collisions. So it is the relation between resistivity and relaxation time which will help us to understand the increase in resistivity in case of conductors. Now we know the relation which we already have derived. Current is NEA VD. This is something we have already derived. Using this relation we will proceed to derive the above relation. So we will write NEA. In place of VD, I will write the expression for drift velocity which is E, capital E upon M into tau. Remember we got it from V equal to U plus AT. For this U is 0, acceleration was EE by M, that is force by mass, and time is relaxation time. From there we got this relation. So we are getting I equal to N E square A tau upon M into E. This E can be replaced by N E square A tau by M. This E can be replaced by V by L because E is V by L for uniform electric field. Now I can be written as V by R. I can be written like this, N E square A tau V by ML. V gets cancelled on both the sides. Now I am left with 1 by R. I will take the reciprocal. R is equal to ML upon N E square A tau. ML upon N E square A tau. This is R. I have taken the reciprocal in the next step. R is nothing but rho L upon A, the factors on which resistance depends. So it is ML upon N E square A tau. L gets cancelled, A gets cancelled. All we are left with is M by N E square tau. We are able to relate resistivity with relaxation time and we have arrived at the proof of this particular relationship. Now what has it to do with this particular reasoning? It clearly tells you that if all the parameters, what is M? Mass of the electrons, N, number of electrons per unit volume, charge on an electron. If all these terms are constant, then resistivity is inversely proportional to rho if all other terms are constants. If all other terms are constant. Then what it is indicating is when you increase temperature of the conductor, the random motion or the motion of electrons increases because they gain more kinetic energy. We already know that kinetic energy and temperature, they are directly related. So with increase in temperature, kinetic energy of the individual electrons increases. With increase in kinetic energy, their collision frequency increases. They become more energetic and hence they collide more frequently. When they collide more frequently, then the relaxation time, that is the time duration between two collisions, automatically decreases. And when relaxation time decreases, resistivity increases because if all other terms are constant, means mass of an electron, obviously, number of electrons per unit volume, charge on an electron. If these are constants, then rho is inversely proportional to resistivity. With increase in temperature, we are increasing the kinetic energy of electrons. When kinetic energy of electrons increases, they become more energetic and they try to move ahead with more energy, and in this process, the collision frequency increases. They collide more frequently. And the relaxation time decreases. With relaxation time, decrease in relaxation time, resistivity increases. This is the situation with conductors. So we have understood the reason for increase in resistivity with increase in temperature in case of conductors. Thank you.